Okay, Mr. Jackson. So we're starting off with deriving the good old quadratic formula, which is ax squared plus bx plus c equals y. Uh, so for solving it, you're just gonna have this as 0. So let's start off with our first step of moving our c over. Oh, always good thing to remember when you're actually solving for a formula and how you want it to look, you want to look at your end product, which I find really, really helpful. It helps me remember it. So good old divisor bar, b square root b squared minus 4 a c 2a. So we know that our common denominator is 2a already, so that's really nice. Now this is going to use that one trick. It's not difference of squares, that's a different thing. Maybe it is? I don't know. They all have funny names, like the zero product property. Whatever, nerd. I just do math. Numbers go in, correct answers come out. I don't explain it, but this is how you derive it. So you're going to move your c over here. So you're going to subtract c from both sides. 0 minus c is just negative c. So ax squared plus bx equals negative c. Sweet. And then let's divide this side by a. I like doing it like that. I don't like when you, like, why cut it up? Why cut it up? Actually, yeah, that is kind of a bad way of thinking about it, because then you'll think of this as together, and then you'll just do that. When you can't do that because they're being added and they're not multiplied. So I suppose that is a better habit to break it apart, where it's a there and a there. These two a's are a form of 1. 1 times x is just x, or 1 times x squared is just x squared. So whatever, screw that a then. So now you have x squared plus bx divided by a equals negative c divided by a. All right, we're getting somewhere. We already got our a from here, so that's cool. And we also have negative c and some other stuff. Now let's see what we can do now. Okay, so yeah, this is what I learned in Bosman's. Honestly, I'm gonna be honest, yours is a really good way of doing it, but I like Bosman's more. So we're just gonna use b divided by 2 squared, and you just add that to both sides, and it makes it so much easier. Where you do the thing where you cut them in half, and you make the box method, and then you subtract this amount that's in this box, and it's what? No, just take this, divide it by 2, and put this thing on it, and it's so much easier. So this divided by 2 is just effectively multiplying this 2 right here, this 1 right here in the divisor, 1 times a, by 2. It just makes it easy. So x squared plus bx divided by a. So that's our original b term. That's what our b is going to be in here. And that's what our c is going to be for our perfect trinomial to get this factored. So it will be plus b divided by 2 squared. So bx divided by 2a squared. And since you're adding this to the left side of the equation, you also have to add it to the right side, so over here. So equals negative c divided by a plus bx divided by 2a squared. Good. This is equal. Well, not equal, but I effectively just added the same number to it, so I didn't change it. So it's still the same. Let's see. Okay, so perfect trinomial. Sorry, it's a little slanted there. We got a slope here. I don't know. Anyways, yes. So you're gonna take parentheses, your first term, and since it's normally x squared, you would half the power of it. Take your sign, drag that down, so your plus, and then half of this, bx divided by, and since half of this is just dividing it by 2, it's also equivalent to multiplying it by 1/2. And, well, 1 times this is just the same thing, and then 2 times a is just 2a. So you just get that. It's really nice. Squared. So this entire thing condenses into this, which is really nice. And then we got the same thing over here, negative c divided by a plus bx divided by 2a squared. All right, breaking point. So let's see what we have in relation to the quadratic formula. So we have 2a, and we have 2a again. Oh, okay. So this is bx, and this is 2a. So I'm going to break this up, and I'm going to distribute this. So I'm going to keep this one for this square root here, because I'll square root both sides and get rid of this. But this one I can distribute onto them. So I had to have 4, because that's 2 times 2. That's what power does, duh. And 2a squared with my bx squared. Wait 1 second. I have consulted my notes and just looked at this. I am stupid. Okay, so first off, let's address what mistake I made. So I was talking too much and looking at my camera, and I added this x on accident. That's why. So I was supposed to just do b divided by this, and technically this x is actually here, and it's multiplied by this. And this is the b term. The x is not included. So addressing your mistakes is always a good thing to do in math, and that's very mature. That should be totally bonus points. Not really. So your x's would not be there, I believe. Yes. Because this is the c term. This doesn't have an x in it. There's no x. There's no x in this. So I don't know where I went wrong with that. I'm just being silly. It's 11:42. I've had a really long day. Okay, give me a little break. Where was I? Okay, distributing. So I was right about one thing. I do want to distribute this. So this would turn into b squared divided by 2 to the power of 2, which is 2 times 2 equals 4. Easy. A squared. Because you're putting this on everything in there. All right, and then plus, yeah, so that would be here. So I'm just going to erase this, and so this is what it's simplifying into, or, not simplifying, sorry. It's, I forgot the word. Providing, I don't know, I'm just coming up with the word providing right now. Either way, we need to make the denominators match. These do not match at all. But I do see one thing. So we have this square root here, and when we're going to have to, or not square root, we have a square here, and we're going to have to square root it later to get this x by itself, and we'll eventually have to subtract this. So we already know that our common denominator will be 2a. Boss, look, the quadratic formula says that, but whatever. So we're going to have to square, we're going to have to square root this, and that's going to take us to 2a anyway. So we need to get our denominator to 4a squared. So how do you get a to 4a squared? Well, you just multiply it by 4a divided by 4a. 4a divided by 4a is equal to 1, which is okay. You're not messing with the equation there. So that'd be x plus bx divided by 2a. Put that in there, equals, so what's 4a times negative c? Actually, since I want to go in the order of the equation here, I'm going to put the b squared divided by 4a squared first. So b squared divided by 4a squared first. And since these now, the a times the 4a will have the same denominator, I can add them. Well, in this case, it's subtract because there's that. So it would be minus c times 4a. Well, since it's a -1, I would probably add that to the 4 instead of putting it on there. Like, why would you do that? Then I'd have to write a multiply thing there and there. Like, that's stupid. And besides, it doesn't look like the quadratic formula anyway, which does stink. 4 times a times c. And this is all under 4a squared, by the way, because these are multiplied, and this is all in there. So you're just adding these two top numerators with the same denominator. Let me move this 4a squared over to the right here. 4a squared. All right, nice. Now you can see the next thing to do, obviously. It's this. It's an atrocious little thing. We're going to square root that. And since we're doing that to the left side, we also have to do it to the right side. So this entire thing is under a square root. Now, one of the cool rules I love about math is all the rules they have. You can simplify so many things with all the cool rules. So when it's real numbers, you can, like complex numbers like I and stuff, it does not work for this. But it's not really our a and b terms here, but it's a divided by b, all in a square root. It's actually equal to the square root of a divided by the square root of b. And that is a beautiful thing right there. That is just, I love that. I love the formulas. They're so cool. So we can actually partition this off. So first off, this square root and the square cancel each other out. So now we just have x plus b divided by 2a. I keep writing the x there. I've already addressed this. I'm not supposed to put the x there. Just ignore that. I never wrote it. You never saw that. Okay. And since we've just discussed this, I can do the equivalent of b squared minus 4. I'm just going to do it in parentheses now because I might as well. C all over 4a squared, and then a square root there, because according to this one, it's all real numbers, so it's okay. And then, well, okay, we can just figure this one out. So we just did this over here, just crossed out the square root and the square, so we can just do that over here, square root and the square. And since there's also a 4 here, what's the square root of 4? 2. So I'm just going to erase the square it previously had, erase the 4, replace it with 2. Now we have something remarkably similar to this. Most peculiar. Bear with me, we have one more step. So I'm just going to, this would go over here. I can just save time by not writing that. You can piece that. And then we're going to just subtract b divided by 2a. Subtract b divided by 2a from both sides. So that would also be subtracting b divided by 2a from this side. And that is not underneath the square root. So I'd probably put it to the left of the square root to make it nice and even. So x equals negative b. So the plus or minus is implied here because it's a square root. I mean, if you have the, what's it called? It's just the way that square roots work. They always have the plus or minus. Since that I already have it in the base equation, actually I didn't have it. I totally had it there, guys. Since I had it in the base equation, I'm just going to put it there. Hey, I went with the line. B squared minus 4 times a times c. All over 2a. Yay! Quadratic formula! And we know this works. Just to solve for a, because we got it from the thing we're solving for. Solving from to solve for, which is x. X is so fun. It's so cool. It's the answers. Okay, bye-bye. I'll see you on the next question.